Hello and welcome to lesson 20 of additional maths with Mr. Barrow. Today we're going to be looking at using factorials, the factorial function on your calculator, to arrange n items. So when we want to say how many ways are there of arranging these 7 things in a row, and we're going to use factorial to do that. Okay, so this continues our work in the probability chapter. So we started with conditional probability. We're going to move on to now combinatorics. So that's permutations and combinations, the number of ways of arranging things and the number of ways of combining things. Okay, so we're going to start with this worked example. Let's say 7 players, Alex, Beth, Chris, Diane, Ed, Fiona, George, turn up for a netball match. Okay, and we're asked how many ways can we organize them to play? Okay, so in a netball team, there are 7 different positions and there are 7 different players who've turned up for those. So we could, and it'll help us, just show all those 7 different positions, okay, as slots to fill. So 1, 2, 3, 4, 5, 6, 7. Okay, so we have the goalkeeper, we have the goal defense, we have the wing defense, we have the center, the wing attack, the goal attack, and the goal shooter. Okay, and we need to fill each of these positions with one of those players. So I could start with just the goalkeeper. I have 7 choices of goalkeeper. Okay, it could be any of Alex all the way to George. Okay, so let's say I choose someone. So I have 7 choices for the first position. So that's 7 in there. If I've chosen someone, then now, let's say I chose Chris. I now have 6 choices left for goal defense. If I chose someone for goal defense, I have now 5 choices left for wing defense, etc. 4 choices, 3 choices, 2 choices, 1 choice. Okay. So if it was just choosing 2 positions, so goalkeeper and goal defense, okay, I have 7 choices for goalkeeper and 6 choices for goal defense. So for each of the 7 choices I've chosen for goalkeeper, each of those 7 has 6 possible options for goal defense. So there will be 7 lots of 6 different possibilities for those 2 being filled in. So 42 different possibilities for goalkeeper and goal defense. So that's what we do. We multiply the number of combinations there are for each of the positions, and that will give us the number of different ways in which we can organize the team to play. So this calculation, we could type it all out, but there is a quicker way, and it's called 7 factorial. Factorial, so if I had n factorial means n multiplied by the number 1 less than n multiplied by the number 1 less than that, and you keep on multiplying all the way down to multiplying by 1. So it's multiplying the number you have by all the successive integers below it down to 1. So 7 factorial will be 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's 5,040. So there are 5,040 different possible teams I can put out just having 7 players in a netball squad. Okay. That sounds like a lot, and it is. Okay, but naturally you're going to choose people for their qualities, and you're more likely to put some people in goalkeeper than goal shooter, etc. But if everyone was equally likely to play in each of the different positions, okay, and you just wanted to assign at random, any one combination you could choose, there's a 1 in 5,040 chance of you choosing that combination if you chose it at random, okay, because there are 5,040 different possible options. On your calculator, if you want to find the factorial button, it's usually above the x to the -1 button. Okay, so what you do is you press Shift, and then you press the x to the -1 button, and you've got the factorial. So what you would press is for 7 factorial, 7, then Shift, and then x to the minus 1, and then press equals, and you'll get 5,040. Okay? So, here's a question for you. By the way, we're going to do 2 worked examples and 2 your turn. So the first worked example and your turn are relatively simple, and then we're going to step up the difficulty slightly. So the your turn. 15 people turn up for Winterbourne Rugby Football Club. Okay? 15 players. Okay? And there are jerseys that are numbered 1 to 15. Okay? So each player has to pick up a jersey and put it on for the match. How many different ways can the jerseys be assigned? How many different ways can we assign those jerseys? Okay, pause at this point, have a go at the question, write down your answer, and then think, is that answer reasonable? Okay, I'll go through the answer now. So yes, if you've done it right, you have a ridiculously large number. Okay, so what you should have done is there were 15 different possible options. I'm not going to write them all down, but the first jersey number 1, you have 15 different people you could give that to. Then you've given out a jersey, you have 14 jerseys left. Then 13 jerseys left, etc. So it's 15 times 14 times 13 times 12, etc., all the way down to times by 1. That is 15 factorial. And 15 factorial is 1, let me get this right, 1,307,674,368,000 to 10 significant figures. Okay. So an incredibly large number of ways in which we can assign the jerseys. Okay. But again, we probably assign them in order of, the number 8 shirt would go to the person who plays number 8, etc. So usually it's not that difficult to assign them. We wouldn't do it randomly, but if we did do it randomly, then there would be more than 1 trillion different ways in which we could assign the jerseys. Okay. All right. So now for a slightly more difficult example. Let's say we have 7 cutout cards. Okay, so we have 7 cards in front of us, and we want to see how many different 4-letter words can be arranged from these 7-letter cards. And by the way, words, I'm taking a word to be any arrangement of 4 letters. It doesn't have to be in the dictionary. So, for example, A, B, C, D would be a word, even though abacad is not really a word. Okay, so any 4-letter word is anything that can be arranged with 4 of these 7 letters. Okay, so I want to know how many different 4-letter words can be arranged. Now, I could try and write down all the different possible options. Okay, so A, B, C with D, A, B, C with E, A, B, C with F, and it would take me quite a while. Okay, a better way is to think logically. I have 4 different spaces in which to put my cards. Again, think, how many different options do I have for that first letter? I have 7 different options for my first letter. My first letter could be an A, could be a B, etc. Once I've chosen my first letter, I now have 6 cards left to put into my second letter. So 6 there. Then I have 5 different choices for my third letter, then 4 different choices for my fourth letter. So the calculation will be 7 times 6 times 5 times 4, which is 840 different words. Now, I would like to have another go at the following question, and then I'm going to tell you a way in which we can get this answer without having to write out the calculation in full. Okay? So, your question is, how many different 5-digit numbers can be created from the 8 cards given below. So the cards are 0, 1, 2, 3, 4. So I'm using 8 cards, 5, 6, and 7. Okay. So how many different 5-digit numbers can be made from these 8 cards? So pause now, have a go, have a think, and write down your answer. So if you've done this right, you have 5-digit number, so you have 5 spaces in which to put these 8 different cards. Okay. In the first space, you could put 8 different cards. Once you've chosen a card, you have 7, then 6, then 5, then 4. So it's 8 times 7 times 6 times 5 times 4, which is 6,720 different possible 5-digit numbers from those 8 cards. Okay. Now, the following bit of work is just for your algebraic interest. And it's a way of doing those calculations using a new function which will be introduced more and more in A level. Okay, so here is a formula. This formula is for the number of distinct arrangements, okay, of R items chosen from a squad of N items. So distinct arrangements. So arrangements are not distinct if they are the same. Okay, so the number of distinct arrangements of R items chosen from a squad of N items. Okay, so like if you had a squad of 18 players and you wanted to choose a team of 11, okay, you would use this formula. So the formula is NPR, and it's on your calculator. You'll probably notice if you look at it at your calculator, you'll find somewhere where it says NPR. It's a shift one. It's something above a key. Have a look for it. And the formula for it is N times N minus 1 times N minus 2 times, and you keep going down all the way down to N minus R plus 1. So in the previous one, when I did choosing 5 items from 8, I did 8 times 7 times 6 times 5 times 4, okay? Which is 8 times all the way down to 8 take away 5 but plus 1. So 8 take away 5 would have been 3, but we went 1 up from that, okay? Or the other way of doing this calculation is N factorial divided by N minus R factorial. Okay, so that's the formula of how to choose a squad of R from a possible N options. Okay, and we're going to just practice that with the previous example. See if we can get 6,720 using our calculator. So we're choosing from 8 different items and we're choosing 5 of them for a 5-digit number. So it is 8P5. On your calculator, you type 8 shift times. So on my calculator, it's above the times symbol, okay, above the multiplication symbol. So 8 shift multiplication, then 5, and then press equals. And that gives you 6,720. And using the formula, if you didn't have a calculator, it would be 8 factorial divided by 8 minus 5 factorial. And 8 factorial divided by 8 minus 5 factorial is 8 factorial divided by 3 factorial, which gives you 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. And you can see you can cancel the 3 times 2 times 1 with the 3 times 2 times 1, and you'll be left with 8 times 7 times 6 times 5 times 4, which is the calculation we did when we sort of used common sense to answer it. Okay, that's just for your algebraic interest. And this letter, the P, is known as permutations. It's the word we use for it's the way we describe how many arrangements there are. It's called a permutation. There are, in this question, 6,720 different permutations, okay, of the objects. Okay, what you should do now is you should go and you should practice from the textbook, exercise 10.2, so the second exercise in chapter 10, okay, which will start you on your process to being able to answer more difficult permutation and combination questions. Okay, next lesson, I will take you even further down this path. Go and enjoy.